So before we can get into the binomial theorem, we first need to understand Pascal's triangle. So this triangle over here in pink was credited to Pascal, that was actually used by many mathematicians before he was even alive. And this pattern becomes significant when we're expanding binomials, which we'll get into in a little bit. But the way this works is we always start with 1, and then to find the next number, we take the two numbers above it and add it together. So 1 plus 4 is 5, 4 plus 6 is 10, 10, 5, 1. And you can see this is pretty quick, so I could do the next row pretty easily, and so forth. What these are these are going to be our coefficients when we're expanding our binomials. And again, we'll kind of get into that a little bit more in just a second. However, because this triangle takes a while to make, especially if we're going to something like the 12th or 20th power, we also can use combinations, which is actually a formula, to get the same values. And we're going to talk about this notation in just a second. But if I wanted to represent this row using combinations, this row would be 5, 0, 5, 1, 5, 2, 5, choose 3, 5, choose 4, and 5, choose 5. So let's break down what that actually means, what those parentheses mean. So for the formula, if I wanted to figure out let's say I wanted to look at this one right here, 5, 2. 5, 2. We should know, because we've already expanded it out, that it should equal 10. So let's look at how this formula works. So in your calculator or on paper, you'll often see it with the C, which stands for combination. So this is 5C2. And to actually evaluate this, we're going to put it into the formula. So in this case, n would be 5 factorial. R is 2 factorial. And then 5 minus 2 factorial. So if we evaluate that, factorial means you multiply 5 times 4 times 3 times 2 times 1. You stop when you get to 1. Over 2 times 1, and then 5 minus 2 is 3, so 3 times 2 times 1. Okay, and then these terms cancel out, so I end up with 20 over 2, or just 10, which is exactly what we had in our Pascal's triangle. So both of these ways are valid ways to get our coefficients. However, combinations are going to need to be used once you get to larger numbers, because it's going to take too long to use the pattern to write out Pascal's triangle to the 20th line. Okay. Also, you can use your graphing calculator to find these values, and I have the steps for you here. So if you have a TI-84 Plus, you just hit the math button, and then you scroll over to prob, and then hit number 3, NCR, and just fill it in. If you don't have the plus, then you would need to type in the top number first, and then hit math, scroll over to prob, pick 3, and then hit the bottom number. Both of those things will give you the coefficient. So let's go ahead and practice using the formula to find these values, or Pascal's triangle, either way would work. So for this one, we have 6, choose 4. So my n is going to be 6, and my r will be 4. So for this formula, we're going to have 6 factorial over 4 factorial times 6 minus 4 factorial. So if we expand that out, 6 times 5 times 4 times 3 times 2 times 1 over 4 times 3 times 2 times 1 times 6 minus 4 is 2, so 2 times 1. I can cancel some of these out, and I end up with 30 over 2, which is 15. Let's look at the next one. So same idea, except n would be 12 and r would be 9. So I would have 12 factorial over 9 factorial times 12 minus 9 factorial. So I don't have to keep writing out these numbers, let's think about this for a second. If I start to expand 12, I have 12 times 11 times 10 times 9, and it's going to go 9, 8, 7, 6, and further. I see that there's a 9 factorial on bottom, so I'm just going to stop here and write 9 factorial, because that'll represent 9 all the way down to 1. And then on the bottom, I'm going to leave it 9 factorial. 12 minus 9 is 3 factorial, so 3 times 2 times 1. So this just saves a little bit of time because I know that 9, 8, 7, 6, etc. is going to cancel out with 9, 8, 7, 6, etc. on the bottom. So if I work this out, I'm going to simplify a little bit. So this would give me 4. This would make that 5. So I end up with 220 over 1, or just 220. So to calculate with a calculator is pretty easy. So if you're not sure, go ahead and look back at those steps from the previous part of the video. And this should come out to, we're putting this in as 12C7, and that comes out to 792. Okay. So now we're going to put those combinations to use by doing our binomial expansion. Now this looks super intimidating. In class, we did a discovery activity so you could kind of see how this pattern works. And once we do an example, hopefully it won't look as scary, but we're just going to follow this formula. So just a couple of quick things. N is going to be what power we're using. So you can see n is always at the beginning of C, of our combinations. And then we break this down into our first term plus our second term, okay? And that would be A and B. So let's just start by expanding this. I think by looking at an example of one with numbers, it will make this a little bit easier to process. So if we want to expand x plus 2y to the 6th power, well, we know right here that n would be 6. Our A is going to equal x, and our B is going to equal 2y. So if I want to plug this in, we're first going to start with 6, always 6, C0. We always start with the 0 on the right side. My first term, x, is going to the power of n, so 6. And then my second term is going to the power of 0. Okay? And what's going to happen is we always start, the first term goes to the highest power, and the second term goes to the lowest power. And then our first terms are going to count down, and our second terms are going to count up. Okay? So for the next one, we would have 6C1. Now our first one is going to go down a power, and our second term is going to go up a power. And we're going to do that till we get to the end. So we have 6C2, first term goes down a power, second term goes up a power. And then again, 6C3, first term is still going down, second term is going up. 6C4, first term going down, second term going up. Almost there. 6C5, first term down, second term up. And then slide this over a little bit. Last one, 6C6, first term to the 0, and our last term to the 6th. Okay. So I know that's really long, but if we look at our powers, right, on our first term, we went 6 5, 4, 3, 2, 1, 0. And we did the exact opposite on our second terms. We started at 0 and went 1, 2, 3, 4, 5, all the way up to 6. And then we have a lot of calculator work to do from here. All right, so if we're typing this into our calculators, 6C0, we learned how to type that in on the previous part of the video. So 6C0 comes out to 1, x to the 6th, and then 2y to the 0 is just times 1. Okay, plus 6C1 is just 6, x to the 5th, and then 2y to the 1st is just 2y, plus, we're on this one now, 6C2 comes out to 15 times x to the 4th, 2y squared, so 2 squared is 4, and then y squared. And we're going to keep on going. Now we're on this one. So 6C3 comes out to 20 times x cubed times 2 cubed is 8, so 8y cubed plus 15 x squared. 2 to the 4th is 16 plus, this one's going to be 6 times x to the 1st, and then 2 to the 5th is 32, y to the 5th, and then lastly, finally, we've got 1, x to the 0 is 1, and then 2 to the 6th is 64, y to the 6th. And then finally, we can simplify further, and we end up with x to the 6th plus, I'm going to put my coefficients together, so 6 times 2 is 12, x to the 5th y plus 15 times 4, 60, x to the 4th y squared plus 20 times 8, 160, x cubed y cubed, 15 times 16 is 240, x squared y to the 4th plus 6 times 32 is 192, x y to the 5th, and then finally we have 64 y to the 6th. So this would be the expansion of x plus 2y to the 6th. So instead of sitting here and doing x plus 2y, x plus 2y, and doing that 6 times, and then having to FOIL 6 times, we can use this method to get to our answer quicker. Even though that seems like a pretty long process, I assure you it is quicker than FOILing a bunch of times. All right, I'm going to go through one more quick example just to make sure you guys got the hang of it. So in this one, again, we've got n equals 5, a equals 2x, and then b equals negative 3y. That negative is important. So we're going to start with 5 because n is 5, and then we always start with 0. First term to the highest power, which in this case is 5. Second term to the 0. And the rest of this I'm going to speed up without talking over it. Okay, So from here, we're just going to plug in everything into our calculators. Just double check your exponents should start at 5 and then decrease on your first term, and then they should start at 0 and increase on your second term. All right, so plugging into the calculator, we get so double check and make sure that you got the same things that I did. When you are working these ones out, be careful with your negative. When you do the -3 to even powers, it's positive. When we do the -3 to odd powers, it's negative. So that's why this kind of kept alternating here. And then we're finally going to put all of this together and simplify it, and we end up with the following. We're going to do 5 times 16 times -3. All right, and that is our expansion. So in this video, you should have learned how to use combinations to find the coefficients in Pascal's triangle. We also talked about how to continue Pascal's triangle. If it's short enough, you could use that instead. We also learned how to expand binomials using those coefficients and using our calculators. Thanks for watching.